I'm going to create a new abstraction in the abstractions folder, which is going to be the iDomain event interface. So this is the interface representing all of the domain events in our system, and a domain event is something of significance that has occurred in the domain, and you want to notify other components in your system that something has happened. I'm going to use Mediator to implement my domain events. So I'm going to add a new NuGet package to the domain layer. I'm going to use the Mediator contracts, which only contains the interfaces required for using Mediator. I'm going to use the iNotification interface and make the domain event implement this interface. Mediator notifications are used to implement the publish-subscribe pattern. We're going to be publishing our domain event, and we could have one or more subscribers to this event that want to handle it. The next thing that I want to do is to slightly update the entity base class. I'm going to add a list, which is going to be a private and read-only one, so it's going to be hidden inside of my entity class and is going to contain the domain events that are raised on this entity instance. And then I'm going to add a few methods that are going to be necessary for implementing domain event support. We want to be able to fetch all of the domain events on this entity instance. We also want to be able to clear them. And the most important one is we want to be able to raise a domain event when something happens in our domain layer. For that, we have the protected method, which is called raisDomainEvent. It accepts a domain event instance, and it just adds it to the internal list of domain events. Later in the course, I'm going to show you how to publish these events using Entity Framework Core and Mediator. With the support for domain events in place, let's go ahead and define a folder inside of the users folder, which is going to hold the relevant events. Let's go ahead and add our first domain event, and I'm going to use a record to represent it, and it's going to be called the user created domain event. Here's what the implementation is going to look like. It's going to implement the iDomain event interface, and it's going to accept a single property, which is the user identifier of the user that was just created. And now all that's left to do is to go back to the user entity, and right here, before returning the user, we want to raise this domain event by passing in a new user created domain event instance, and we can pass it the ID of this user object. Now, when we persist the user object in the database, we are also going to publish the user created domain event. Someone can subscribe to this event and execute some behavior asynchronously. An example of that could be sending a welcome email to the user when they register to the Bookify system, or doing some background work to further set up the user so that they can use our system properly. How are we going to persist an entity inside of a database or any other persistence mechanism that we're using? For that, I'm going to introduce the repository pattern, and I'm going to start by adding a new interface, which is going to be my iUser repository. I'm going to add two methods inside. One is going to be the getById async method, which accepts a user ID and returns a user instance if it exists, and the other is going to be the add method. The add method is going to allow me to add the user to the repository, but what is going to be responsible for persisting the user? For saving changes to the database, you can use the unit of work, and I also like to define that abstraction inside of the domain project. So I'm going to add the unit of work interface, and I'm going to define one method on it, which is going to be the save changes async method, which is going to take any changes that are pending in our repositories and persist it in the database. The unit of work and the repository pattern are necessary for defining a rich domain model. When I talk about repositories in the domain-driven design sense, I look at them as entity repositories, meaning that my repositories can only operate on my domain entities. This can even be further imposed by using generic constraints which require the repository's type to implement the entity base class. Let's go ahead and define a respective repository for the apartments. So I'm going to add another interface in this folder, which I will call iApartment repository, and it's going to have one method inside, which is the getById async method. We're going to be using this later on in the application layer to execute the required business operations. Now let's introduce another feature folder in our domain project, which is going to contain our bookings. So I'm going to create a bookings folder, and of course we're going to start by adding our booking entity. So let's define the class. I'm going to make it sealed, and it has to implement the entity base class. Let's add the missing constructor, which is going to accept the booking ID and pass it to the entity base class. I'm going to add the properties that are required to represent a booking. You can see we have the identifiers of the apartment and the user, which help us to identify what is the user making a booking for which apartment. We have a date range value object, which I haven't yet defined, representing the duration of this booking. Then we have the price for the duration period, the cleaning fee, the amenities upcharge, the total price, an enum representing a booking status, which we are also going to introduce, and a few datetime objects representing some interesting information about the booking. Let's go ahead and introduce an enum that is going to represent the booking status, and I'm going to add the relevant booking status values. So we have the reserved, confirmed, rejected, cancelled, and completed booking statuses, and now the booking status property is looking okay. Let's introduce the date range value object, which represents the duration of our booking. So I'm going to add the date range type. The date range value object encapsulates two date objects, and for that we're going to use the date only type, which is available in .NET and in many databases, because we only care about the date component of a date time. We have the start and end of this date range. We have a helper property which calculates what is the length in days of this date range, and then we have a create method which we can use to create a new date range instance, and it's defensive because it ensures that the start of the range can never be greater than the end of the range, in which case it's going to throw an application exception. Now the booking entity has a rich domain model in place, but it's missing a constructor. So I'm going to add the missing arguments in the booking constructor, and we're going to assign them to the relevant properties. I'm going to make the booking constructor private because I want to be creating it using a factory method, which is going to allow me to do some interesting things. Let me show you what I mean. We're going to add a static factory method, which I will call reserve. It's going to return a new booking instance. And what are the arguments that I'm going to need on the reserve method? I'm going to add the apartment ID, user ID, duration, and the current time arguments for now. And if I try to create a new booking instance by calling the constructor, we're going to see that we are missing some properties. So we can set the booking ID. We can also pass in the apartment and user ID and the duration of the stay. But then we are missing a lot of the pricing information that is required for a booking. And how are we going to calculate all of this? For calculations like this that don't naturally fit the responsibility of your entities, you could create a domain service. So I'm going to create a new class inside of the bookings folder, which I will call pricing service. I'm going to define a method inside, which is going to be called calculate price. On a high level, what it's doing is saving the currency of this apartment's price, and then it's calculating the price for the period's length in days, so effectively multiplying the apartment price by the duration of the stay. Then we have some interesting logic for calculating the upcharge for specific amenities that are available on the apartment. The business decided that a garden or a mountain view incur a 5% upcharge, air conditioning is a 1% upcharge, and parking is a 1% upcharge. We add all of these together to come up with the final upcharge, and then if it's greater than 0, we apply the upcharge to the price for the current period by multiplying the percentage points. Then we try to calculate the total price by starting from 0, adding the price for the period. If the cleaning fee on the apartment is not 0, then we're also adding the cleaning fee to the total price, and we are adding the amenities upcharge to the total price regardless. And then we finally return all of this inside of a pricing details object. Let's introduce the pricing details type, which is going to be returned from our pricing service. It's going to have the money instances inside representing the relevant properties of the pricing details. Now if I go back to the pricing service, you'll see that everything is fine except this call here, which is the call on the money value object, checking if this value is 0. Currently, the money value object is defined here in the apartments folder, but this value object is relevant for our entire domain, so it makes sense to move it out of here and into some sort of shared folder. So actually that's the first thing I'm going to do. I'll add a new folder, which I will call shared, and I'm going to grab the money and currency value objects, and I'm going to move them inside. I'm going to add the is0 method. It just checks if the current money instance is equal to a 0 money instance, meaning that the amount is 0 and the currency is none. This could introduce some subtle bugs in our code, so I'm going to add another overload for the 0 method, which is going to accept a currency. And then it's going to create a new money value object, but with the given currency. And then what we can do in the is0 method is compare to the 0 money amount with the same currency. Also, I'm going to update the pricing service here to use the currency that we are using for calculating the price. Now let's go back to the booking entity. I'm going to add another argument here, which is going to be the pricing details of this booking, and now we can complete our method. So this is going to be calculated in the application layer by calling the domain service, which is the pricing service, and then we're going to pass the result of this to the reserve method. Let's complete our constructor, and we also want to raise a new domain event to notify other interested parties that a booking was just reserved. I'm going to introduce an event in the bookings folder, which is going to represent the booking reserve domain event. So let me first create the events folder, and then I'm going to create the type. So this is going to be the booking reserve domain event. And here's what it's going to look like. It's going to accept a booking ID, and it's going to implement the iDomain event interface. So if I go back to the booking entity, I just need to add a using statement, and I can return my booking instance.